Let's look at the homework for frequency distributions here. This first one is qualitative data, and basically there's 4 different values: freshman, sophomore, junior, senior. So the table is pretty easy to make. You just list out the 4 categories, and then you got to find out how many there are of each one. And then you can always add these together to make sure you haven't missed one. And then this is the bar chart here. So this is kind of like your frequency distribution table. Your bar chart, you have the different categories along the bottom, and these are the frequencies. And notice with the bar chart, the bars are separated because you have different independent categories. Okay, they don't share a boundary. And then so that someone can interpret the graph, you need to have a title. So this is class standing for a sample of 25 college students. Then you got to have labels here. So underneath is class standing, and these are the number of students. And so that would be organizing qualitative data. So all the other ones are organizing numerical data, and there were 2 ways to do that. There were single value groupings and grouped frequency distribution tables. I meant for one of these 3 to be a single value grouping, and somehow excuse me, somehow I overlooked the fact that all 3 of these were grouped frequency distribution tables. And that's okay. The single value grouping is a lot like this, except you have the numbers in the middle of the bars and the bars are touching. But the group frequency distributions, these are the ones that involve a lot more work to them. Okay, so when you do this, they're going to tell you how many classes to use. So this says use 6 classes, and then you're going to use that when you determine the class width. And you do that by taking the maximum value minus the minimum value and dividing that by the number of classes. When you do that, in this case, you get 84. Okay, this is where you always round up. You never round it down. You always round up to the next whole number, because you want these to be whole numbers. And then when you construct the table, you start with the minimum value, in this case 30. You add 84 to get the next lower limit, and then you subtract 1 to get the upper limit. Okay, you add 84, subtract 1, add 84, subtract 1, on down the line. Okay, so when you actually subtract these 2, you actually get 83. You get 1 less than the class width. But the class width here is 84 because this class includes both endpoints. It includes 30 and 113. Okay, but if you take 113, subtract 30, you're taking 30 and everything below it away. So that's why if you subtract these 2 limits, you get 83, not 84. Okay, so and that's also why when you add 84, you get the next lower limit and subtract 1 to get the upper limit. Add 84, subtract 1, add 84, subtract 1, on down the line. Okay, and then I use the tallies to make sure I get the correct number in each class. So this is the number of observations in the data set that's in each of these intervals. And then I always add them up to make sure I get the total number of observations in the data set. And in this case there was 29. And now to make my frequency distribution table, what I'm doing along the bottom is I'm putting these lower class limits: 30, 114, 198, 285, 366, 450, and then this one would be the next lower class limit if you had a next class, which you don't, but you're going to use the next lower class limit. Okay, and then these bars, it's going to go up to the frequency, okay, for each one of these. So now the important thing though is it's going to start at the lower limit and go up to the next lower limit, and then the bars here are touching one another. So for a numerical distribution, this is a histogram and the bars actually touch one another. They actually share that boundary. And so what you would say is that this class goes from 30 all the way up to, but not including, 114. And this next class would be 114 all the way up to, but not including, 198. So what that means is each of these classes includes the value on the lower boundary, It goes all the way up to, but does not include the one on the upper boundary. So if you actually lie on a boundary, you actually belong in the next class up. Just like you normally round up, you would belong in the next class up. Okay, so again, you need a title, money spent on textbooks by a sample of 29 students, and then this is the money spent on textbooks. This would be the number of students. And you know, one thing is I gave you distributions that didn't have very clear shapes to it, and this is a very strange shape. Like I say here, I would say it's probably a little right skewed. You got a lot of data over here, not as much here, but it doesn't go down and then leave a space and then have an outlier. Okay, it actually goes up at the end, and that's very strange. And you don't see that all that often, but you do see it in this case. Okay. Let's see here. The next one. Oh, I don't have the next one. I have the wrong thing here. Let's see. I need to grab it here. It's down here. Okay. So this is the third one. The amount of time spent reading the newspaper. Okay. And so I find the class width. It tells me to use 5 classes. So the maximum minus the minimum divided by 5. And then I round up to 8. And so you start with the minimum value, add 8, subtract 1, add 8, subtract 1, add 8, subtract 1. Okay, and then you get your classes, and then you find the frequency for each class, add them together to make sure you get all the classes. And so then here's your histogram, and so along the bottom you have your lower class limits. And then each bar goes from the lower limit up to the upper limit, and all the bars are touching because they share that boundary. And now your title here, don't forget that, minutes spent reading newspaper by sample of 24 readers. So this is the number of minutes, that's the number of readers, and this is a right skewed distribution. And then finally, this last one here. This is the number of minutes internet subscribers spent on the internet during their most recent session, it says. Okay, so I take, this tells me to use 7 classes, so I take the maximum value minus the minimum value, divided by 7, and then I round up, so the class width is 12, and so you start with the minimum value, add 12, to get 19, subtract 1, add 12, subtract 1, on down the line, find the frequencies, and then for the number of subscribers here, let's see here, for the number of subscribers, it goes from it goes from the lower limit to the upper limit, sorry. And the height of each bar is the frequencies, and this is the shape that you get. And again, they share the boundary, so the bars are touching. And these are your lower limits here. These are your frequencies. And so my title here says number of minutes spent on the internet during recent session for a sample of 50 internet subscribers. A big title there, but that makes it very, very clear. In other words, you don't want just internet here, minutes, frequency, because then someone couldn't interpret that. You really want your title to be such that they can interpret the graph, okay? This is the number of minutes, this would be the number of subscribers, and that would be the answer to number 4. So I hope this little video helps you either review and remember how we did these, because you'll have some questions about this on the test. And possibly, if you didn't do it correct, hopefully seeing the answers to these and having it explained will help you see what you did wrong, so that when the test comes, you can do well on the test.